Welcome to the Construction Show, everyone. We are filming another episode from WEFTech. Today we have TOMCO on the show. Very interesting company. They're covering a lot of applications in a lot of different, or an application that covers a lot of different sectors. So we're going to get into a lot of technical information today. We've got Jeff Holyoak. He is the VP of Strategy and Market Development at TOMCO. And we have Camila Hess. She is the Sales Application Engineer at TOMCO. Jeff, Camila, welcome to the show.
Jared, we really appreciate it. Appreciate the opportunity to talk to you.
Yeah, thank you so much. We're happy to be here.
I just realized as we're starting, if you had Jeff, if you had been moved over like 7 inches, someone could have watched the interview and scanned the barcode that's right behind you. Yeah, there you go.
Give me the opportunity right here.
We'll bring it up on screen. Send it to us. We'll bring
it over here too. It's fine.
Yeah. Send it to us. We'll pop it up on screen. Actually, we should do that, Gowdy. We should add that in. Okay. TOMCO, I got introduced to you just actually a few weeks ago. So you're a new company for me. Maybe Jeff, let's start with you. Just a high bird's eye view of who the company are, how long you've been around, that basic information.
No, absolutely. So TOMCO Systems, we've been around about 55 years. We are basically anything to do with CO2, from the capture of CO2, liquefaction purification. We can, the storage tanks, transportation equipment, any kind of application equipment, whether that's dry ice, whether that's fire suppression, but most specifically, in one of the biggest markets that we operate in is water treatment. So you can utilize CO2 or carbonic acid that we produce, that Camila will introduce more about that here as we go on. But you can use CO2 to lower pH in water, drinking water, municipal water, but also industrial water applications. So that's really what we're focused on. And so our parent company is a company called Air Water America, a subsidiary of Air Water Inc. out of Osaka, Japan. And we are basically an industrial gas conglomerate. And so we are a gas distributor, we are a gas producer, and any kind of gas, not just CO2. It's hydrogen, helium, oxygen, nitrogen, argon, any type of industrial application gas. We basically can produce it, store it, transport it, distribute it, and have all the application equipment that goes along with it. But on the TOMCO front, it has anything to do with the CO2 and the CO2 applications.
So are your clients, are they with the parent company on all that supply? Are your clients often tied in with the other arms of the company, or is there a direct to market for TOMCO?
TOMCO's direct to market. So our customers are usually EPCs or vendors to municipalities for large build outs of drinking water facilities. So we have over 1,700 global installations at municipal drinking water facilities, most of those being in North America. We've been in the water treatment space for about 30 plus years now. And so we provide them directly all the equipment from the storage tanks to the carbonic acid solution processing systems. We do the installation, the piping, annual maintenance programs, preventive maintenance programs, monitoring of the systems, you name it. We do everything in between. So yeah, we are direct to end user or direct to application agents within that space.
Okay, so Camila, let's bring you in on this. Let's focus in on the water treatment. Can you break down? I feel like this is going to be one of those interviews that I'm going to be trying to keep up. So just leave me behind. I'll keep up as I need to. Can you sort of break down maybe a typical system? I see one like just on the bottom. I guess that's your bottom right. That's got tanks. It's got the TOMCO Systems.
Yeah.
Can you just break down maybe a couple standard configurations just to sort of give us an overview?
Yeah, absolutely. So on the water treatment aspect, so we are taking liquid CO2, we're vaporizing it, we're taking a pressurized stream of carrier water, we're injecting the CO2 into that carrier water, and we're forming carbonic acid. So we're actually pre-reacting the CO2 with that carrier water supply, as opposed to a direct gas injection application. So from that, so a typical system would include, as you see behind me, a liquid CO2 storage tank, right? That storage tank is also coupled. It has our typical tanks for water treatment, or our C or cabinet style tanks. That is shown in that picture to my right there. But essentially in that cabinet enclosure, you have your refrigeration panel, you have your first stage pressure regulator, your vapor heater, your pressure building vaporizer. All of that is pre-piped, pre-wired, pre-installed, so the contractor doesn't have to worry about installing that ancillary equipment in the field. So that's a lot easier on the installs for the contractor. So that's typical in a water treatment setup is those C-series tanks. Those can go anywhere from 3 3/4 ton all the way to 120 ton. Now from that, since you're vaporizing the CO2, you need vapor to the process at our pressurized solution feed system, or PSF. So that is essentially what the bread and butter of the carbonic acid formation is, right? So our PSF system is the one formulating that carbonic acid solution. So at that application point, so we can dose as little as 0.5 pound an hour of CO2 all the way up to 3,000 pounds an hour of CO2. So those systems very much range in sizes and footprints, just depending on that CO2 consumption. So your typical package would include that storage tank, the PSF, a carrier water booster pump skid to pressurize that water and recirculate it, and our carbonic acid diffuser, which is actually the controlling orifice for that system.
Let's talk about our Heavy Industry World Tour brought to you by Savinaw Equipment. Find, market, and sell surplus and used equipment. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. Pumping systems. They're the heartbeat of manufacturing, but they can be real headaches, can't they? Vibration, pulsation, back pressure, it's a wonder anything gets done efficiently or safely. That's where Blaco comes in. Their pulsation dampeners, back pressure valves, and other solutions are designed to tame the chaos, improve efficiency, and add reliability and safety to your pumping system. Imagine less downtime, lower maintenance costs, and a whole lot less stress. That's the Blaco difference. Blaco Industries, smooth flow, smooth operation, made in the USA. Visit Blaco.com to learn more. As heavy machinery specialists for construction, SMS Equipment knows performance, like the performance they achieve together in a partnership dedicated to the success of their construction customers. At SMS Equipment, they're more than machines from trusted brands. They're the people beside you today and every day, bringing industry-leading technology and expertise to your job site. Because the right partnership makes everything possible. SMS Equipment, partners in your possibilities. Discover what's possible at smsequipment.com. Did you know cementitious binders can be responsible for up to 70% of the total GHG footprint of mine backfilling processes? Now you can replace up to 50% of the binder in your mine backfill operations with Graybond, Graymond's new low-carbon cementitious binder. This lime-based alternative binder maintains a 40 to 70% lower GHG footprint compared to typical cement and can adapt to varying mine conditions without compromising performance. Learn more about Graybond at graybond.com.
I just need to back up a little bit because I've gotten such a influx, of course, at WEFTech of water treatment information that I'm trying to separate everything out and find in where things insert into the workflow. Where does your system come into a process? Can we just back it up from like the bird's eye view of that? Where do you plug in?
Sure. That's a very broad question because it depends on the application. So let's say you're doing some form of line softening process. You're going through a reverse osmosis membrane train, right? So you would plug our system in. So it's a reverse osmosis train. And then you're adding alkalinity back into the water at that application, right? Because reverse osmosis or a membrane train strips all of that alkalinity out of the water. So now you have a corrosive water stream. So to mitigate that and deal with that, you're adding some form of lime slurry solution back into the water to increase your alkalinity. Now, after that, immediately after that process is where our system would come in, right? So now you have this alkalinity back into the water. You've reduced your corrosiveness, right, of that water stream. But now you have a higher pH, right? So that's where carbonic acid comes in, which is a benefit here in using that as opposed to a mineral acid, right? So mineral acids deplete alkalinity. So while they do neutralize, they are actually taking away your alkalinity, which you don't want in this scenario. So carbonic acid actually neutralizes your pH while simultaneously just changing the type of alkalinity in your water stream, right? So it's not depleting your alkalinity. You're maintaining your overall total alkalinity. It's just converting those carbonates, protonating them with carbonic acid and changing them to bicarbonates. So if you look on a pH to alkalinity graph, they're actually directly correlated. So in that application, that is where we would install our PSF. So it just really varies by application.
Okay, I want to jump into case studies because I think this will help sort of drill down to really real world applications. You have one here, Camila, and thank you for sending these through because it's going to be very helpful.
Sure.
You have a sulfuric acid versus CO2 case study here. Can you walk us through exactly what and it's always nice when you have the counter of a system because then you can kind of see the difference. So can you walk us through that particular case study?
Yeah, so that particular case study that was done by an engineer a few years back, kind of doing the comparison of upfront both capex and operating expenses and overall safety factor of sulfuric acid versus carbon dioxide. So upfront, get straight to the point, oftentimes carbon dioxide is going to be a higher upfront capital expense in comparison to a sulfuric acid, right? So sulfuric acid systems, I mean, if you really wanted to, you could go get a tote and a metering pump from Home Depot and set that system up for just maybe a few $1,000s. Of course, municipalities have a more intricate, complex system, so it's going to be a little higher of a capex than that. But CO2, with our systems and our bulk storage tanks and our PSFs, can be a higher upfront expense. However, that study does show that in the long run, again, dependent on your usage and consumption of both, comparing consumption of sulfuric versus CO2, in the long run, it actually is a benefit to use carbonic acid because it's not as harmful on the infrastructure of your equipment, right? So carbonic acid is a mild acid. It's soda water, right? You can drink soda water versus a mineral acid, which is highly corrosive. When it comes in contact with piping systems, a lot of the times it just eats away at that infrastructure. So the replacement and maintenance and everything that ties along with a sulfuric acid system in the long run can often be more costly than just having a carbon dioxide tank and a PSF panel, right? Because you're just flowing soda water, which, again, non-corrosive, non-harmful to the environment, non-harmful to operators. So in that specific case study, all in all, in comparison, the sulfuric acid system ended up being, although a little bit cheaper up front, it ranked worse on a safety factor and overall operating expense over a period of like 20 years. So
I want to.
that's kind of a basic summary.
When it comes to balancing the growing demand on your grid with the growing need for more responsible, sustainable energy production and generation, you need the right partner. A partner who delivers long-standing grid expertise from a team dedicated to your unique needs, and one who supports that team with innovations designed for the future needs of your grid, while being rooted in proven electrification excellence. ABB is that partner, offering solutions that meet technical requirements, regulatory compliance, and recognize the need for sustainability in your business operations, as well as in the lives of the surrounding communities. Solutions that expertly blend physical services and solutions with next-level digitization. Solutions that enable safer, smarter, more sustainable operations. ABB is the name to trust to help modernize your grid. Learn more at abb.com/CA. Join us in the depths of the mining world, where global leaders and industry giants converge to shape the future of mining. From groundbreaking technologies, advanced machinery, revolutionary safety measures, to sustainable initiatives. This is the voice of mining. This is Mining Now. Showcase your company to millions worldwide. Book your episode now. Visit crownsman.com.
Okay, so on a system like that, if there's I asked this question on another interview and it was like 90%. This was on a chemical for removing stuff off steel and treating water with chemicals and things like that in big production facilities. And they said it was about 90% of their systems are working on off legacy systems that could be upgraded. Where does TOMCO fit into that? Like a system like you're talking about, how many people are doing it on a legacy system as opposed to what you're offering the market?
A legacy system in terms of they've been using a sulfuric acid system for years, and so what would be the benefit of a switchover? Is that what?
Yeah, essentially, yeah.
Okay, yeah. So in that sort of scenario, I mean, I've done plenty of pre-designs with engineers where they've been using sulfuric acid for years. I mean, and just because it is cheaper, right, up front, but they don't see the need to switch over to carbonic acid until there is a pain. And that's just the truth of the matter, to be totally honest. So, and I've had an operator come up to me with sulfuric acid burns all the way up his arm, and asking hey, how do we convert this legacy sulfuric system that we have installed over to carbon dioxide? And so I think trying to get that message across that it really is a safety factor in keeping your operators and owners safe, and also just maintaining the longevity of your equipment, right? If you purchase a capital equipment line, right, you'd want to maintain that over 20, 40 years. With a sulfuric system, it just gets a little bit trickier, right? So kind of because of the corrosiveness of that acid, and it can damage your equipment and the surrounding environment. So kind of trying to explain that to those people that are still utilizing sulfuric systems is essential.
So that's oh yeah. Okay, I just want to quickly ask this.
Jump in there and just add to that a little bit.
Is the opportunity then for TOMCO often when it's at the end of a 30, 40-year equipment or product cycle that they now need to upgrade, a municipality needs to upgrade, a plant needs to upgrade, and now there's that opportunity for you to step in because now they are going to make the investment in because that old system has corroded the equipment. Is that sort of where there's an opportunity there?
There's definitely an opportunity there. I mean, I've had a few even in the past year where that's been the case, where they're just sick of trying to upkeep that equipment.
Right.
I had a customer where they're having to replace their tank every 10 years because it's just eating away at their piping. And so at that point, since that, instead of replacing that damaged equipment, now they're looking at turning over into CO2. So that, yes, that is a specific area where we're wanting to target.
Jeff.
Yeah, no, I was going to say that question really dovetails right into kind of the market opportunity. So absolutely, yes. If you kind of like what Camille said, if you don't have a pain, you view the sulfuric acid and the corrosion and all those other aspects of it as cost of doing business, because that's the way it's always been done. So are you really going to go replace that system with a whole new system today? No, not until it's kind of at its end of useful life. And then you'll start assessing that. In the municipal water market, I don't know the exact number. I'd say, we probably have 60 to 70% penetration over the last 30 years of displacing sulfuric systems. There certainly still are many of them out there, but in the municipal space, that market is pretty strong.
TOMCO just individually? Sorry, TOMCO individually is 60%? Or just those systems in general?
CO2, and TOMCO has a high majority of market share in that space. The real market opportunity and the opportunity, environmentally and safety and everything else is in not municipality, but in the what we term as the industrial space. Anybody that just has a discharge permit. You're displacing water. You're having to lower your pH for discharge, whether it be a mine or a chemical application plant, things like that. That market penetration for the use of CO2 is probably in the single digits, and it's a lot of that is just the lack of awareness and knowledge of that CO2 is an opportunity, and it can be utilized in that type of application. And it also is upfront a much larger capital expense. So when you're talking about, drinking water in municipalities, not wanting to utilize chemicals, because, the downstream effects in water streams and kind of tributaries and everything else that we kind of, where some of this water goes to, those are negatively affected by some of those chemicals that we put in the water, where CO2 is actually a benefit. So in a municipality, that's a positive. When you're just discharging your water, it's just an expense. So you're trying to just comply with your permit. So yeah, that capital expense is kind of burdensome. But when you look at that long-term cost advantage of that case study that you're referencing, and you apply that to a limestone mine or a chemical plant or a power generation system, those are great opportunities to kind of convert those over. And that's really what we're talking about the most here at WEFTech this week, is trying to educate the market and understand, where is that cost curve? Where do we need to be for the ROI for it to make sense to get away from some of these mineral acids like a sulfuric and use CO2? And I mean, the biggest message in all of this is we always view CO2 as a negative, right? We're trying to get rid of CO2. Well, one of the best ways to get rid of CO2 is find constructive uses for that CO2. And water treatment is absolutely one of them. You actually can take the CO2 and it all but sequesters it in the water. As long as that water stays under pressure, which, if it goes out to a lake, it goes out to a river, goes into the ocean, it's sequestered in there naturally. So you've taken CO2 out of the atmosphere and using it constructively instead of generating more chemicals using these chemicals, causing corrosion, building more infrastructure. So there's huge positives in there in the long term for these. And that's really the biggest market opportunity outside of the municipal space.
So I was sticking with that outside the municipal space and the industrial space. If you meet a company while they're in the design phase, that's sort of where you can really shine, because then you can lay all that out, the life of the equipment and all that. That case studies, you can make that very clear before they actually break ground, right?
Yeah, absolutely. That is what my job is, right? So my job is to get in front of engineers, continue to educate on carbonic acid versus a mineral acid, the benefits and how our product line is 95% or greater efficient, right? That's what the efficiency of our pressurized solution feed panel is. So my job is to get in front of these engineers, explain all of this, and write the spec, right? So when that specification comes out, if it is a contract bid pre-design sort of scenario, our goal is so the specification is solely written around our product line, right? That is where we come out on top, and that is how we measure, or I myself measure success of how well we are penetrating that market.
You have a couple other case studies that you sent me. Can you, Camila, are there, maybe we won't go through all four. There's a mining application one, there's a Brom Mate, and a lime one. Maybe pick two of those and maybe walk us through it a little bit as well.
Yeah, absolutely. I'll start with the Brom Mate one, because that one's interesting to me. Surface water, right? So if you're pulling water from, let's say this specific case study is for Alameda County in California. So they were pulling water out of the bay, and that water has a high bromide concentration. They were hitting that water with ozonation, right, for disinfection. But their issue there was that if you take a highly concentrated stream of water that has a lot of bromide in it, and you ozonate that water, it actually produces bromate. Now, bromate is a carcinogen, right? And you clearly don't want that in your drinking water. So if you actually adjust the pH prior to ozonation, you significantly reduce the amount of bromate produced from ozonation. So that is an application where our equipment was introduced into that Alameda County waterway. We showed significant efficiency in reducing the amount of bromate produced from ozonation. So that's essentially what that bread and butter of that case study is.
Yeah, again, very layman question, but what is your origin of bromate in the water? Is that from some sort of production that's being fed into the water feed, or is that a naturally occurring thing?
It can be a mix of both. From the Bay Area, I think it's just more of a naturally occurring source that occurs sometimes in surface waters. So,
and so, sort of walk us through the implementation of. So they had an existing. Their setup was they basically tested the water and they found certain levels, so they know, okay, we need a system here. Now, were they replacing an old system, or was this a whole new system of infrastructure?
This is a brand new system that we specifically designed for Alameda County. So that is where how our system was implemented.
Okay, so this is what I want to just quickly cover as well. Well, I actually doesn't need to be that quick. But from day one of talking to them to the system's actually fully in place, what are like a few stages that you're going to go through in a scenario like that?
Yeah, that's a good one. So water world can be a year from the moment you initiate a conversation with somebody till you get the specifications and it goes through a contract bid and you bid on it and you win it and the equipment gets installed maybe within a 2-year time span from that first conversation. Could be 20 years. It just depends on how that project is funded, right? So the initial stage of, let's say, on our municipal market, right? So we have a very expansive rep network on the municipal side, expanding all over 50 states. So we get in with our reps. They know their territory. They bring the leads into us. We have those conversations with the engineer that need pH adjustment, right? So that is the origin of where those conversations, those seeds that we implant are.
I see.
So, and so from there, we take a look at what their current setup is, take a look at the application, whether that be bromate reduction, corrosion control, lime softening, well rehabilitation. We look at their setup. We design a system that's very, very pre-engineered towards whatever their setup might be, and their process implementation is. And from there, it goes through pre-design. It goes through 30% design bid specifications. And we pull it all the way up to the 60% design specs. It continuously kind of fine tune it in between those stages in a typical contract bid design.
So
all
this
the
is
way up
still
to
the bidding
90%.
process. This is still in the bid. You're designing during the bidding process. So that's a
Yeah,
long,
can.
wow.
It is. And so that's why I say it could take a few years, it could take 20. I fully am well versed in understanding that you have to build up your pipeline and continue. Understand that this might be a little bit of a longer sales cycle, right? But you have to build up that pipeline and continue in that momentum of education with the engineer,
Yeah.
so that at that 90% design bid specifications, hopefully you're sole source. If not, you're named, right? TOMCO or equal, or TOMCO and no other, right?
So at the 60%, so at the 60% stage, you might be with 3 other companies that they're all going through, and then 90% hopefully it's done. I see why you're wanting to push harder into the industrial and commercial space.
Yeah. The municipal world is it's interesting. The dynamics of how everything functions between us as the OEM, our rep firms, the contractors, the consulting engineers, all of it is a
Right.
very
Just layer after
enjoy that
layer.
Is it? It is a lot of layers and a lot of complexity, and it takes a little bit of the learning curve also to understand how it all works.
Is
too.
it also an advantage? And both, I'd like both your thoughts on this. Is it also though an advantage, like for us when we want to push into the mining space? Construction. There's all sorts of media around construction. Mining, there's not really anybody doing what we're doing. There's a few people that are trying now. It was very hard to get anybody to talk to us, but once we got in, now it's sort of like we're protected because it's still hard to get in for anybody else. Does TOMCO kind of run into that where you have this expertise, you have the market penetration, so now you do get to be sort of first up for some of these process designs?
Yeah, absolutely. I mean, especially on the municipal end. I mean, I would like to say that we are the market leader for carbonic acid feed solution systems. So for pH adjustment on the municipal side. Now, on the other side of that coin is the industrial market, right? So we mentioned mining. We have a few, and this ties back into the case studies that I provided for mining. So we have successful mining installs, whether that be wastewater or process water on mining, right? So on the process side of stuff, we have an install up near Juneau, Alaska, where they are separating lead out from mine drainage in a flocculation basin. So they used to use sulfuric acid, and that is one of their systems where they had a legacy sulfuric system, and they used it, and it would corrode their way at their pipes, and they got sick of having to replace that infrastructure, so they switched over to carbonic acid. So in that specific scenario, we are treating to separate out lead, right? So, but we're also, there might be another application in mining where they might just have high effluent wastewater discharge that they have to fine tune down to a 6 to 9 pH range, which is mandated by the EPA to discharge. And so on that end, that is where our installs lie. Now, it is a little bit harder on the mining side, as you mentioned, because a lot of the times people don't want to talk to you until you get your foot in the door. And so luckily we've made partnerships with our municipal rep firm is Misco Water in California, but they actually are trying to put forth the initiative to get more into the industrial space. So we actually have a partnership out of their Arizona office that is a major mining contact, and he's been in the mining industry for over 30 years. So I think us right now in that market sector are just trying to structure it a little bit better so that we do get our foot in the door, we do get our education and message across, and then now we eventually in the future can expand that into that industrial market sector a bit more.
And not take 20 years to get a system in place. I'm guessing the mine you're in Alaska didn't take. I'm guessing they took 6 months from approval, right?
Yeah. Industrial, harder sell, but quicker sales cycle.
Exactly. Jeff, anything to add?
Municipal is not for the faint of heart. You've got long sales cycles and strong or extended working capital outflows. And even when a project starts, even after we start our project, it could take 2-3 years to ultimately close that. And, we're waiting in line for other things to happen. So you also have to, price it correctly and, the time value of money and everything else that goes into it. But as we said, we've been doing this, that side of the market for over 30 years. We're experts at it. We are the global leaders at it. And we will continue to do that. But the other opportunities is exactly what Camila and you were just talking about. It's just, take the mind space. It is really an education, and it's an understanding of where are the benefits and how ultimately this is going to benefit, each mine, each facility long term, and the opportunities that are there. Getting in front, that's why having this conversation right here is so important for us, because we want to hear from more minds. We want to get more case studies and prove this model. We know the technology works. We've been advancing it for 30 years. And so it's really just now we have a great technology that needs to find its home in these industrial spaces and find the right kind of, cost curve and find that right, intersection of where it makes the most sense, so we can stop using some of these other acids and damaging products for the environment, for the market, for everything, and find that, like I said, that intersection there that makes sense for everybody.
I'm quite excited to ask my next.
Yeah, then 3 to 6 months, no problem. We can get you installed. Right?
Every project. You mentioned you kind of alluded to cost overruns in municipalities. I wanted to look it up before I said it, because it's such a crazy number that I wanted to make sure. So in North Shore, this is in Vancouver, British Columbia, where we live. So this is in Canadian dollars. So you can kind of deduct 35% or so. They had, I think it was originally in 2018, it was estimated 700 million was expected on their wastewater treatment plant. It is now at 4 billion.
Oh my gosh.
Wow.
Yeah. So, and this is going to be, from what I understand, someone can fact check me on this, but I believe what they're going to do is, at least in part, distribute that out as basically an extra tax on everybody, of course, to pay for this slight miscalculation. Okay. How do you
get any extra?
But that's my question. How do you deal with those types of things where you're supposed to put in a plant, you've estimated at this time, but things get delayed, and then there's maybe halfway through the process, a new regulation comes into place? How do you approach that? You talked about patience, but it's on the bottom line. It's a major issue. I was quite curious about it.
Yeah. And Jeff, feel free to chime in here, but currently now it's just the name of the game, right? So, I mean, I've had projects that go, well, you bid on it, you work on it from the pre-design, and this one was actually up in Canada. But
Oh no, got a theme here.
And we get named, and we're feeling good about it, and it's going really good. We bid on it. The award date was supposed to be December of 2023. We're now in October of 24. No update yet, because that project went significantly over budget. So they had to go back and ask for more money. And I'm not hearing an update probably until the end of this year, possibly beginning of next. And so in that scenario, I don't really have an answer for you as to what we do. It's honestly a waiting game. Maybe the project comes back alive again in certain scenarios where times you think the project is dead, there wasn't sufficient funding, it didn't get approved, this, that, and the other. And you wait a few years, and then your rep calls you up and says, hey, actually, this project finally got funding, and it's moving forward. So there's not a right now, it's kind of just a waiting game. And maybe Jeff has some more insight on how to deal with that.
But just sorry, Jeff, I really want you to, I was just wondering though, but while that's happening, I mean, even our travel costs now, I mean, they're probably 30% higher. We just did Mine Expo in Vegas, and a bottle of water was a little bottle, and it was like $11.
Oh, I was there. I paid $40 for a kale salad. That wasn't that great.
Okay. It wasn't just me. It was insane. Yeah. It was insane.
Yeah. Yep.
So what do you do? Do you have anything to add to what Camila's talking about? Because it seems like a real issue.
It is definitely getting worse. And I think a lot of these, because we're a small component of that. So you talk about a $700 million project, something of that size, we might have been 500,000 to 1.5 million of that number.
Sure.
So, we're not making a material impact, and our price is our price. So our price didn't change. We have to factor that in, like that time value of money. If we don't think our delivery is going to be for 2 years, obviously, we're going to factor that in of when
Right.
we're going to get paid. We're going to get paid when we're buying materials, and make some estimations of what the price of steel or carbon steel is going to do over the next year, 2
Right.
years.
So you're just factoring all that stuff in to the, yeah.
Yeah, and unfortunately, you kind of have to err on the higher side on some of these when you're making these long range ones. Most of them aren't that large. Yeah, 700 million is a pretty large overall contract. 4 billion is crazy. That's it's a huge number. But so they don't get extended that long. But a couple 2 to 3 years once these projects get started. And I think that's changed into this bid process. It used to be you compiled all these bids, somebody won the bid, we were named, somebody was named for various component pieces in there. You know what it costs, you know what's going to do, you know who's responsible. And now they have these design bid kind of contracts where basically it's like you're going to get $700 million and you contractor EPC,
Yes.
you get the whole project. Here's your check. It's up to you to figure out what happens there. Now that's had some major downstream negative impact.
Yeah, I've heard of these.
Now we were spec'd in, we were bid in, but now they're going to say, well, I only have X amount of dollars. I'm going to go as cheap as I can find. And I'm not saying anybody cuts corners or anything, but you're going to look to cut costs wherever you can. And some of these name contractors or name components are no longer going to be used. And so you don't necessarily get what you originally signed up and bought.
Right.
So I'm sure some of that feeds into these cost overruns, and some of those cost overruns are the reason that they're going that direction.
Yeah.
The municipality just basically says, here's my budget. Who's going to be able to get the job done for this budget?
Yeah.
There you go. The cost overruns, that is your problem.
Okay.
So you really have to focus on contract terms and things like that to make sure that we're not exposed to be kind of downstream impacted negatively by some of these other overruns that they start kind of trying to attach those to everybody else on the list.
I want to just because I took it in sort of a negative direction on when it goes wrong, which I mean it's just part of anything municipal or any application. But
any large construction project.
Yeah.
Sure.
What is an example of it going, not a specific example, but what system works really well? And I'm talking about on the municipal side. And the U.S. is kind of unique in this fact that how the states are set up. It's like we've done transportation episodes, and the regulations are so different from state to state. What is an example of an environment in a municipality where it does go really well? The timeline, is it red tape? Is it the type of engineering firm? Where are sort of the markers that this is a good project?
To me, Camila deals with it more directly on a day-to-day basis, but we equate a lot of the successes to our reps, to our agents, the Miscos that you talked about, the Moss Kellys, the Peltons that we deal with every day, every year, and have for many years. They manage that project, and they do such a great job with all the component pieces that they're applying to that, and the contractors that they work with or that are employing them and their services. That's what a vast majority of these go well. So yes, there are always overruns, and the bigger the construction project, the more overrun risk you run. And the numbers, when you start with the law of large numbers, the bigger the project, the bigger the overrun. But our reps are outstanding, and like I said, we've got 20, 30-year relationships with these, and we keep them and maintain them because they are so critical to ensuring these projects go on time, under budget, on budget, and that's been really the key to success for us.
Camila, anything to add?
I completely agree. Like Jeff was saying, our reps are hitting the ground every day. I mean, they drive up and down in their territory, and they call on engineering offices, and they visit plants, and they understand operators' pains, and they have a variety of different line cards. And one of their water plant operators might say, we're getting funding for a plant expansion within the next couple of years, and we're going to need pH adjustment. Do you have anybody that can do that? And that's when your rep, who is knowledgeable on your product line, like a Misco, right? They say, yeah, absolutely. I have a company called TOMCO Systems that can help you out with that. And from there, they are the ones that say, hey, Camila, come out. Let's do a couple ground bag presentations and sales calls together. just to educate a little bit more on this technical product line. And then that's when I get in front of the engineer and I, explain all the benefits of utilizing carbonic acid for pH neutralization. And then from there, that turns into, hey, we'd like a budget estimate at this point. And so I'd fully pre-engineer that project at that point. Maybe not fully, but just a baseline kind of skeleton. Hey, here's a budget estimate for this specific application. And then, a few months, hopefully, or maybe a year goes by, and then that fully gets implemented into a specification contract bid. So we really owe it all up to the rep relationship, honestly.
And just pulling that information.
Industrial space, yeah, that we're gonna see the same level of success long term as in the industrial spaces, whether it be mining or chemicals or whatever the market vertical is building those rep relationships, and then ultimately with the engineering firms. And we do all the engineering in-house for all of these. We fully support them, but getting in front of these individual customers is key and critical. And so, as we continue to build out that rep network for those products and those markets, that's where we're going to see the ultimate successes.
I got one question for each of you. Camila, over to you. When you get into these, when the rep brings you in for the conversation, typically how educated are people from sort of that day one? Is it pretty ground up? Was it like someone like myself? Don't worry, I won't be offended. Or is it someone that already has a pretty good understanding and they sort of need you to go into the details?
So the newer, younger engineers will definitely need you to go into the details. I mean, it is, to me, it's obvious. Yeah, carbonic acid makes your pH go down. But these are engineers you're speaking to, so they're going to be technical. But at the same time, they don't know your product line, right? The newer ones, at least. They're not very familiar with it. So I do have to get into the nitty gritty, ask the questions. Hey, how long of a reaction time is it? Where do I need to put my probe? But maybe the more experienced engineers that are familiar with your product line, and we've worked with major engineering firms like Jacobs and Stantec and CDM Smith and Brown and Caldwell. And so we have a little bit of a rapport with their more experienced engineers. And so they'll understand your system to a high level. But I think it's still important to go through the technical specifications, especially because you do see those new faces and newer engineers that are very much so curious about your product line and want to know more and want to know about what the applications of pH adjustment are. So yeah, it's I give very high level answers to questions, and I give very, very nitty gritty specific questions. So it varies.
And that would be applicable in the industrial sector as well, I assume.
Absolutely.
Yeah.
Yes. Yeah.
Jeff, what is sort of
new? So yeah.
Yeah. What is and then just sort of last question to you, that when we're talking about things like green technology and being carbon neutral and that, how do you sort of package that message? Was it at the end of the day, the company still needs to be an investment that's worth making? How do you sort of package that as sort of a sales and marketing approach on industrial and even municipalities?
Yeah, no, absolutely. We have a real simple saying in all of that is you have to be in the black if you want to be in the green, right? So it has to be cost effective. We all want to save the environment. We all want to be carbon neutral, but none of us want to pay extra for that. So we focus on that, the development of markets and products that will help get us there. So when you talk about how to package some of that, like I say, part of that is let's stop thinking about CO2 as a negative. There are some great applications for CO2. It's all around us, and let's put it to use and effective use. And another way of doing that, where we're really focused on now, and the technology is slowly getting there. The cost curve isn't quite there yet, but we're going to get there. And I think this market, especially in whether it's municipal drinking water or industrial drinking water, but we can capture the CO2 out of the atmosphere, purify it, liquefy it, and then ultimately integrate it into these systems. And you can be self-sufficient. You don't buy CO2. You're capturing the CO2 from potentially some of the emissions that you're emitting from your own site, and then integrate that into treating the water, that whether it's your discharge. So the circular economy of all of that is, you're capturing some of your own emissions and cleaning the water that you were dirtying up. You're not buying more chemicals. You are carbon negative at that point. So when the technologies, like I said, the technologies exist now to do direct air capture. We have all the rest of it after that. And we have multiple partners now that we work strategically with on direct air capture and other source captures for CO2. It's really just, again, getting down to getting enough volume and the cost curve of that to make it make sense. But I feel like we're probably 2 to 5 years away from a kind of a really true total marketability of it. But there's certain applications where it does make sense today. And then again, getting into some of the municipalities where they kind of do have more green initiatives. There's federal funding, state funding,
Right,
to do
yeah.
some of these things
To sort of offset.
and operating expenses to offset it. As we get more of those implemented, then just everything else starts to kind of equalize and get down to a common thing. So I see direct air capture to water treatment as the future for water treatment for pH balancing.
Okay, sorry, I got to ask one more question then. Camila, on the technical side, how much has that technology, that capture technology, advanced from 10 years ago, 5 years ago, and 5 years from now? Is it the type of technology that can really continue to evolve?
Capture specifically.
Yeah.
Yeah, and so that's more of a Jeff question, to be totally
Oh, okay.
honest. He'll
Back to Jeff
definitely
then.
know more than me. But I will say I do, we've recently worked on a project where they do have their own direct air capture unit, and they're utilizing that CO2 for pH adjustment down at a petrochemical plant. And that is a full circle approach, right? So they're in control of their own CO2 supply and they're sequestering it into water. So a very green solution, like Jeff mentioned. But and I can fully agree with Jeff also that I can see that to grow. Now, as far as the technological advancement, I'm sure Jeff has some points to that.
Yeah, it's 5 years ago. It wasn't even a conversation. The technologies were kind of there. And there's where we haven't landed on is what is the right technology. And we don't, and as TOMCO, we don't do that front end capture side. We take it after it's already been captured, and we do final purification because you can use membranes or amine systems or other solutions, lime. So there's all sorts of different technologies that are out there. And a lot of the news about it today, and so the Inflation Reduction Act updated and passed in 2021, that really put federal funding to a lot of these things. So you have seen a huge advancement since that time, third quarter 2021. Now, a lot of that technology is going to, how do we capture millions of tons of CO2 and put it in the ground and just store it forever and store it for 100 years and get rid of it?
Right.
That's great. And we need that to some level, but we can't do that forever. So where I see this going over the next 3 to 5 years, to answer that second part of your question, the technologies are now there, and now it's just getting the cost curve down. So it's getting more installations, economies of scale, improving on those existing technologies. You can use an amine system, a solid amine that's capturing the CO2 from air. And when it does it today, you might utilize 10% of the surface area of the solution. If you got up that to 20%, you've just doubled the capacity of that same machine. 40%, you've quadrupled the capacity. So over the next 3 to 5 years, as we have more installations, more applications, and more investment, you will see the efficiency of existing technology advance dramatically. That makes a lot of these other solutions, like we're talking about here, more viable. And so within the next 3 to 5 years, I 100% believe we will see a lot more of that. And it's not just about capture, sequester, it is capture and utilize. And that's the biggest focus.
And there's lots of potential for that technology to continue to evolve. Yeah,
absolutely.
Yeah.
Absolutely. It's really it's still in its infancy.
Jeff, we're covering a lot of like technical ground and information with the case studies and that. Do you have any other sources for TOMCO where people can go in and just learn more about?
Yeah, no, absolutely. So we actually I co-host with another gentleman, Luke Lana, a podcast called Catching Carbon. You can find it on any major platform, Apple, Spotify, YouTube. And we do 1-2 episodes a month, but it's all about exactly what you just said. It's about the supply side of CO2. It's about the education of CO2, the applications, some of the things we talked about, sequestration, the IRA and the Inflation Reduction Act, 45Q, but ultimately the impacts of reduction of CO2 in our supply, but also all the greater utilizations of it. So lots of great episodes and content. We just get experts like yourself on your own applications of things and talk to them and understand what's going on in the market so we can learn more about all these things.
Please do not have me on as an expert in water.
I didn't mind it. Yeah,
I will
all right. That's why I had to sit here and I can't say I sit here and look pretty. I just sit here. So,
You did great. You
Yeah.
did great.
It's great to talk to both you. I'm quite impressed with myself that I didn't go down the mining rabbit trail. We, of course, host a Mining Now show, so I really wanted to take it that. But we stuck with municipalities. Hopefully, we get you back on the mining side because I know, Camila, we've talked about there's lots to cover in that space. But it's pretty incredible what you're doing, and just the market penetration in the municipal side is incredible. So thank you both for joining the show. I certainly hope it's not the last time we do this because we've got lots more to cover.
we really appreciate the opportunity.
Yeah, thank you. It was fun to talk to you.
And and have a good rest of the show at WEFTech. I think you got about a day and a half left. Yeah.
Sure do. Yeah.
Okay, and thank you everybody for watching. We're going to have a link. We're going to have links to, of course, to TOMCO's. It's TOMCOSystems.com. But we have a link to their LinkedIn. I can't talk. Their YouTube channel. Both the guests have a LinkedIn page if you want to connect with them directly. But we're also going to put links to the case studies as well if you want to go in there and read more about these technical sheets. So you can go and, of course, follow us, subscribe on LinkedIn. Thank you for the support, everybody. We will see you on the next episode of The Construction Show.